Logic is an amazing, peerless foundation of mathematics and only mathematics. All other domains of knowledge are founded on the logicalization of the observed behaviors in nature or the laws derived out of knowing nature. At another plane, the logical foundation of mathematics is so powerful that it presents a fascinating exploration of how apparently small innovations actually triggers myriad revolutions. For instance, the introduction of the decimal number system in Europe by Fibonacci in the 13th century did seed the European Renaissance and Europe's coming out of the so-called Dark Ages. In fact, a new logical thread is enough to act as the foundation to build newer mathematical entities and applications. For example, the idea of counting using part quantities led to the conception of fractions, that is, using less than one unit of something as the unit of counting. In turn, fraction powered the idea of rational and thus the real set of numbers. Real numbers provided the ground for infinitesimal quantities, or very, very small quantities. The invention of calculus is based on the idea of limit, only because real numbers were recognized as true, and calculus is at the core of real-world applications of mathematics. The positional number system is also one of those foundational logic in mathematics. It was a mathematical invention that was conceived as the mother of many number systems. It introduced the idea of assigning calibrated weights to digits at the different positions in numbers. Consequently, the core idea of the weights in number systems cannot be appreciated until we explore a few number systems with different assigned weights. That understanding is critical to visualizing quantities and the manipulation of those quantities, mathematically speaking. So much so that most of the properties and behavior of the four foundational operations, addition, subtraction, multiplication, and division, are actually the reflection of the properties of the weights of the digits in numbers. For instance, the division operation works on the dividend from its leftmost digit, unlike the way the other three operations work on the numbers from the rightmost digit. Or how the carry, in addition, is neither 1 nor to the next digit. It all depends on the weight of the number being carried. On the ground, the positional number system is like an encryption system that encodes a quantity into a number. And expectedly, any number can only be read by applying the appropriate key to decode a given number. The positional number system is not a specific encryption system, but a key creator. And then the key is used to generate a unique set of numbers. For instance, if the key is packets of 2, we create the set of binary numbers. And if it is packets of 10, we create the set of decimal numbers. For instance, counting or quantifying a set of given things in multiples of 2, that is in twos, may label the set to be 1, 0, 1, 0. But the same set of things would be labeled as just 1, 0 in multiples of 10 or in tens. Relevantly, 1, 0, 1, 0 would be read as 10 things if the key is 2, and read as 1010 if the key is 10. That stark a difference exists among positional number systems of different encryption keys. If it helps, let it be known that the key of different positional number systems is called the base. So 2 is the base of the binary number system, and 10 the base of the decimal number system. Evidently, we all must learn a few different positional number systems to be able to comprehensively appreciate the DNA of numbers. It is unfortunate that most school systems make decimal as the default numbers and pay little attention, and space to learning the positional number system as a generic encryptor of quantities. Expectedly, cent% mathematics brings you a fairly detailed exposure to a few positional number systems. No discussion on positional number system and the likes of decimal and binary numbers can ever be complete without taking cognizance of many numbers that are informally part of our lives, but are standalone or they are on unique basis. Does month in units of 30 days, week in units of 7 days, time in units of 60, such as 60 minutes being an hour, make more sense as number systems in their own right. Then there are also standalone numbers such as jiffy, pinch, as in coming back in a jiffy, please add a pinch of salt. There are quite a few like these. There is more to be learnt on number systems. What is so particularly fit about binary numbers that they are the default number form in the digital hardware? We do not use decimal numbers for the processing chips for all number crunching. Welcome to the world of numbers for the sake of numbers. Get to the 12-part reels on positional number system. Decode the encryption that number systems are to lay the deepest foundation of operations on numbers. Thank you. With us, you will master all the mathematics you need. Be good to you, not just others.